Hi, hello friends, welcome to my YouTube channel. Now in this session we will solve the Telangana State Genco AE 2015 electrical solutions. Now in this session we are going to solve the problems from the power system here. The question on the screen is, if in a short transmission line resistance and inductance are found to be equal and the regulation appears to be 0, then the load will be. So here in the given question, what they are saying is they have given a short transmission line in which the resistance of the short transmission line found to be equal to reactance of the transmission line. So here what we need to find is what is the power factor. So we know that theta is equal to tan inversion of x divided by r. So this is the theta value. So theta is tan inversion of x by x we can take, so both are gets cancelled, tan inversion of 1, so this is equal to tan inversion of 1, which is nothing but 45 degrees. Now we can find the power factor. So what is the power factor? So power factor is equal to, so cos theta, which is nothing but cos 45 degrees, which is nothing but 0.707 here. So here the question is whether it is a leading or it may be lagging. As we know that the regulation will be 0 here condition. So regulation will be 0 only at leading power factors. So from these two conclusions we can say that the answer is 0.707, leading is the answer. Okay. The next question here is, steady state stability of power system is improved by. The steady state stability limit is equal to EV by X, where E is the excitation voltage, V is the terminal voltage, and X is the total reactance of the transmission line. So here it can be improved by using double circuit line instead of single circuit line. What it mean? So in a single circuit line, for example, say I am drawing a single line diagram. So here we have a bus bar, and here we have a transmission line, and here we have a transmission line. So this is a single circuit line. So instead of using this, suppose if we use this kind of structure where two lines like this means, so here suppose say XL1 and XL2. Okay, so these two are the transmission line reactances. When they are connected in parallel, the net reactance XT is reduces. Okay, XL1 into XL2 divided by XL1 plus XL2, so that XT value reduces here. As the XT value reduces by using double circuit line, so XT decreases here, so that the steady state stability limit improves here. So by using the double circuit line instead of a single circuit line will improve the performance of stability. The next question, during a disturbance on a synchronous machine, the rotor swings from A to B before finally settling down to steady state at a point C on the power angle curve. The speed of the machine during oscillation is synchronous at points. So friends, here the important point to be remembered is the question is asked at the speed of the machine during oscillations here. So oscillations here. So if we draw the power angle curve, in x-axis I will represent it as a delta, in y-axis I will take PA, accelerating power. So if you draw the power angle curve, which seems to be like this, so first the machine is operating at a point A, so because of disturbances it is moved to point C, but the machine is having inertia so that it cannot come to synchronism at this point, so it will move to another point called B here. Okay, so this is the case. So here A and B, these are the two limits for maintaining the stability of the machine. So beyond these values, the system or machine will lose its synchronous speed. So within these two values, the machine has to be at synchronism here. So the question asked is during oscillations. So when you're shifting from A to C and C to B, the synchronous at the points are A and B. These are the limits for the machine, and for these 2 points the machine is at synchronism. So beyond these points the machine will out of synchronism, so stability will loses. So the answer is A and B. The next question here is, if the fault current is 2000 amps, the relay setting is 50% and CT ratio is 400 is to 5. That means primary is 400 amps carrying, secondary is 5 amps carrying. The plug setting multiplier will be. So this is the important question for in case of Tsgenco and Transco or PSUs. So the formula for is the plug setting multiplier is nothing but it is a ratio of fault current divided by CT ratio into current setting. So here the current setting is nothing but the rated secondary current into the relay setting. So what is the rated secondary current of the CT is 5 amps. So 5 into 50%. So 50% means we can write it as 5 into 50 divided by 100. So how much we got here is nothing but 25 divided by 100. So 100 is 2.5 is this value. We will substitute this value here directly. So fault current is 2000 amps. CD ratio is 400 divided by 5 into current setting is 2.5. So if you solve this, you will get the answer as 10 amperes. So that is the answer. Hope you understand this. The next question here is, the reactance relay is normally preferred for the protection against. So it's a straightforward question. The answer is earth fault. Why? Because the reactance relay is independent of resistance. So reactance relay is independent of resistance R. That's the reason why the reactance relay depends upon only on reactance but not on the resistance of the earth. That is why it is usually preferred for the protection against earth faults here. Thank you friends. Thanks for watching my videos. If you like my video, please subscribe, comment and share. Thank you. Have a nice day. Take care.